Move me so you don't have the double vision. Okay, team. Whoa. Okay, so astronomy people, I just want to talk about the lesson on day and night and just kind of give you a recap just to make sure we all can touch base and know what we're talking about, and also so you know what the different levels of answers are expected for this. So what we were talking about were day-night cycles. I'll just switch to the... So, actually, no, I'll keep going. So, they've given us a description here talking about day-night cycles in different parts of the planet. They also talk about what you should be answering, and I just want to give you some of the basics. So, the first thing that we're thinking about is what causes day and night, and where does the sun rise and set in our skyline. So, I've given you guys all a planet, our planet Earth, and I have a light source for you guys. You're welcome to use your phone if you want to work around with me. But what we're thinking about for the first case is here's my planet, this is the sun, the light source, and how is it shining onto our planet. Something to keep in mind is that only half of the planet is going to get sunlight and the other half is not. Are we okay with that so far? All right, so the sun is our light source. The sun is what's causing the daytime. The lack of the sunlight on this side, that is what's causing our nighttime. Are we good with that? Okay, half of the planet's going to be lit. The other half of the planet is not going to be lit. Now, the other thing that's going to cause day and night is the rotation of the Earth. So the Earth is rotating, and as it's rotating, different parts of the planet is going to be exposed to that sunlight and thus causing day. And then the moment that it goes out of the view of the sunlight, it then goes into night. Are we okay with that so far? So these are the basic things that we're thinking about of day and night and what causes day and night, and that is what we're thinking about first. So I just want to point out some of the marking schedules to that exam question you guys did. I did write this one up. So achieve stuff is just recalling the basic things. So recalling that the sun is the light source, that half the planet's going to be lit up, and that the rotation of the Earth is what's causing it to have day and night. The other thing to keep in mind is where the Earth rotates. So the Earth rotates from west to east. So we are going counterclockwise. Counterclockwise. Yes, like that. And by doing that, that means that the sun will rise in the east and set in the west. So like, for example, when we're looking at this globe, let me put the light back up. New Zealand is going to see the sunlight first before Australia will rotate into the sun. Okay? So that's what's causing our different time zones and things like that. That's also why that like New Zealand will experience the new year first before the UK, because the UK is on the other side. All right? It was also an interesting fact. The first country that declared war on Germany during World War II was New Zealand. And the reason why is that New Zealand, time zone-wise, was ahead of the UK. So just a fun fact of how times work. All right, so that's the first thing to keep in mind. I'm just seeing what else. Cool. The other thing that they asked you in this question is they wanted you to think about the United Kingdom, the US, or sorry, I should say Canada, and then New Zealand, and how that's going to affect our day-night cycles and the length of day. So the other thing to keep in mind is that the length of day is obviously going to be influenced by the number of hours that the Earth is going to be exposed to the sunlight based on its rotation. Now, something that we have to keep in mind is that the Earth is at a tilt. It's about 23 degrees tilt. It's not straight up and down. If it was straight up and down like this, then it would be the same day-night cycle consistently throughout the year. So you wouldn't have that variations of longer days, shorter days. Are we okay with that so far? So if the Earth was not having its tilt and the sunlight was just going like that, then the country, wherever it's located, will have the same number of daylight versus nighttime hours. But because we're on a tilt, we then are influenced by where we are in that rotation, our orbit around the planet. So as we orbit around the planet, as we orbit around the sun, we have to be mindful. I'm just going to put the sun like that. When we rotate around it, the tilt does not change. And so depending on where we are in reference to the sunlight, if we're over on this side and we're pointing this way, the southern hemisphere is now pointing towards the sunlight. Yeah? But if I'm on the other side, like this, you see how now the northern hemisphere is pointing towards the sunlight and the southern's pointing away. So that's something to keep in mind. Do you want me to show you again? I see some confused faces. So over here, if this is New Zealand Where's New Zealand? Over here. So this is our summertime. You see how we're getting a lot of the direct sunlight, and the UK over here is up north and it's not getting the same direct sunlight. So that's why the UK is experiencing winter and why we're experiencing summer. And we have opposite seasons because of the opposite hemispheres. When we go through our orbit as a planet, and now we're on this side of our orbit, and now the sunlight's pointing here, do you see how the north hemisphere is pointing towards the sun? So here's the UK. And New Zealand on the bottom is pointing away. So even though it's still doing the same rotation, it is going to be affected by the tilt and how much sunlight it's going to get. Are we okay with that so far? So that's obviously going to influence the day-night. So the rotation of the Earth doesn't change. It's still the same amount and still the same frequency, but it's just a matter of how long is it in the pathway of the light when it's in that rotation. So that's something to keep in mind. And then you have your autumn and your spring as well. Cool. So that is what we're looking at for this question here. So thinking about why New Zealand experiences the longest days and shortest days opposite to at opposite ends of the year compared to the UK. I don't think I've worded that very well. So we're opposite hemispheres, so that's going to influence it. The other thing that we have to be mindful of is how direct that sunlight is. So when we're on this side, we're thinking about angles now. So when we're on this side, you see how the northern hemisphere is getting a lot of direct sunlight, and that's going to be really hot. Think about like when lights are shining at you. When the light's shining directly at you, it feels really hot. But when it's shining at you at an angle, it's not as bright and it's not as hot. So that's why I wanted to give you guys lots of different simulations so you can see different components. One of it is going to be the angle of the light. The other thing to keep in mind is the horizon on where the sun rises and sets. So during wintertime, again, the sun is going to be rising and setting in a lower part of in our sky than if it's up in the northern hemisphere. And then if I flip it around this guy, now we're getting this direct sunlight and they're getting direct sunlight. Yeah. Equator? So the equator, again, this is going to think about the stuff you guys have been talking about with seasons. The equator, regardless of where it is regardless of where the Earth is in its orbit, is always going to get the same direct sunlight. So regardless of where we are in our orbit, the equator still gets very similar sunlight throughout the year. It's direct and it's more or less the same. So we don't see at the equator the same extremes in seasons. So they tend to get the same temperature throughout the year. All right. That also then leads into the Alaska question. So if you find Alaska up here, it's really high north, right? So what happens to Alaska is, and I'll show you guys on this map. So here is America. That's my Alaska bit. So when it's the summertime in Alaska, what happens is the Earth will rotate, but even though it's rotating, Alaska never gets out of the pathway of the sun. Even when it's here, it still has indirect sunlight hitting it. Like that. So that is how places like Alaska and Russia and Greenland and Canada, so Greenland's up here? Yeah. That's how they can get 24 hours of sunlight. Because when this Earth rotates, it never actually rotates out of the pathway of the sun. When it's winter time, and the sun's pointing that way, you see how it never rotates into the path of the sun. So it's continuously staying in darkness. Now, this only happens for maybe like a week or a month out of the year. So it's not consistently for the whole winter or the whole summer, but there's enough of it that it's going to be not having any sunlight on it. Cool? Pretty neat, huh? So we are very much dependent on where we are on the planet because we experience different things. So there's universal things that we experience throughout the planet, like day-night cycles, but there's going to be variations in how we experience day-night. And that's the important thing to keep in mind when you're thinking about the astronomy questions. So I just want to go over and point out to you guys the marking schedule. So that's kind of the things that you're thinking about. When it comes to the marking schedule, Be mindful, achieve is just stating the basic facts. So stating, I know that the sunlight provides the daylight, only half of the earth is going to be lit. The rotation of the earth causes day and night. So that's the basic achieve stuff. The merit level stuff is explaining why. So you're explaining that the rotation is causing us to go in and out of the sunlight's path. This one here is New Zealand and the United Kingdom have opposite winter and summer solstice because they are in opposite hemispheres. Again, the big thing about the merit is going to be linking in the tilt. So the fact that the earth is at a tilt, that means that there's going to be opposite seasons and opposite solstices as well. Are we okay with that? All right. The excellence bit then is going to be looking at that you understand the tilt and you understand latitude is going to be really important. So latitude is going to be a really big factor when we're thinking about astronomy. So, what's the other one? Latitude. What's the other one? Oh, I can't remember the other one for some reason. No. I'm talking about going horizontal. This way. Can't remember the name for that coordinate. Off the top of my head, my brain's having a fart. That's okay. All right, so latitude is going to be the important thing that you're going to be talking about when you're doing the excellence level because different latitudes obviously experience different things. So the higher up, the higher latitude or the lower latitude here in Antarctica. So Antarctica will experience the same thing that the top of the planet also experiences, which is that 24 hours of sunlight, 24 hours of darkness. Hopefully it'll come to me. All right, cool. So yeah, the big thing again for the excellence is talking about location on the planet. And then that's mostly it. Yeah. Cool. I think that's more or less all I wanted to talk about for that. Are there any questions? Does that help you guys with the understanding? So keep in mind with all of these questions that you guys are getting for the astronomy topic, you have to be thinking about the different levels of the answer. Achieve is just identifying, merit is explaining the why, excellence is explaining the nuances and what we experience in the planet. So why do we not get a perfect, like why do people experience different things in different parts of the planet? Okay, did you find the word for me? No. I want to figure out what that one is. Longitude and latitude. Okay. This longitude is this one, latitude is this one. Thank you. I knew they were both L's. All right, so latitude is this one, and then longitude is this one. Sorry, no. Other way around. Sorry, longitude is this one, latitude is this one. The way I remember it's latitude is fatitude, and when you measure fat, you're going around the waist. So there you go. All right. So just be mindful of the different things. So the longitude is what's going to influence what time zone you're in, because that's talking about this bit. And then latitude is going to experience the day-night cycles and your seasons and things like that. Cool. All right. Questions, concerns, comments? All right. I'll stop it there.